able to use the normal distribution. So to be able to use a normal distribution for a sampling distribution, one of two things have to be true. One, they have to tell us that it's normal, or they give us characteristics that the distribution be normal. Or two, the central limit theorem has to be satisfied. What is the central limit theorem? The central limit theorem states that we have at least 30. Our sample size is at least 30. So if the sample size is at least 30, we could say that the normal distribution can be useful to find the probability. So let's look at example 2. A certain strain of bacteria occurs in all raw milk. Let X be the bacteria for a count per milliliter of milk. The health department has found that if milk is not contaminated, then it has a distribution more or less mound-shaped and symmetric. The mean is 2,500. Standard deviation is 300. A large commercial dairy. The health inspector takes 42 random samples in the day. Each of the 42 is averaged to obtain the sample mean. Assuming the milk is not contaminated, what is the distribution of X? Okay, so a couple of things. We basically want to say, is it a normal distribution? So first off, they tell us that it's mound-shaped and symmetric, so that gives us a clue that it could be normal. Okay. Now the other thing I'm going to ask is our sample size at least 30? Do we have at least 30 samples? Yes. So here's what you could say. You could say since n is greater than or equal to 30, this one actually hits both parameters because they tell you it's basically normal. But since n is greater than or equal to 30, by the central limit theorem, or we call it CLT in the hood, by CLT, we say the distribution is normal. So we can use the normal distribution to find the probabilities, okay? Now, if it's a normal distribution, let's talk about the mean and standard deviation. The mean for our sampling distribution, I call that mu of x, the mean from our sampling distribution will be the same as the mean that's given to us in the problem. So the mean will be the same, okay? This is what's different from 6.3, and this is what we just covered. The standard deviation is this. I have 300. Now, if I'm just doing one at a time, it would just be 300. But how many do I have in my sample? How many samples do I have? 42. So I'm doing 42 at a time. So 42 samples. So what I have to do here is I have to divide this by the square root of n. So to find the distribution, the mean stays the same. The only thing that changes, basically, if you just want to kind of simplify this as much as possible, it's just the standard deviation. So you just divide the standard deviation by the square root of n. So 46.291. I'll go 0.291, okay? It's very easy. You just got to make that little adjustment right there for the sampling distribution, and you're going to do the same thing you did in 6.3. You're going to do a great job. Assuming milk is not contaminated, what's the probability of the average bacteria count for the mean or the sample for one day is between 2350 and 2650? Okay, so I'm going to do all my normal curve. 2500 is my mean, between 2350, 2650. Okay, so I could use normal CDF. I'm not doing the Z thing this time. That's a little confusing, I know. What's my lower bound? 2,350. My upper bound, 2,650. My mean is 2,500. Now, the key is, what is my standard deviation going to be? So what's the standard deviation for the sampling distribution here? This is what's different than yesterday. If it was Wednesday, we're doing one, or the other day, we're doing one at a time, it'd be 300. But for the sampling distribution, we'll use this standard deviation. That's the only difference, really. If you want to simplify it, try to simplify as good as I can, that's really the only difference here. So you're going to do a great job on this, but you just got to keep that in mind. It can be kind of tricky, but you're smart. You're a smart person. You'll get this. 46 point. Okay, because we're doing the sampling. We're doing the standard deviation getting smaller when you're doing for the sampling distribution. It'd be 0.9988. So that's my answer.